Hello and welcome to Develop with Dirk. My name is Dirk, and today we're going to be starting with very simple process of code abstraction and pattern recognition. So let me start very simple for you guys. So in coding, we have this process of where we can identify repetition, and repetition can be used to execute multiple lines of the same task. So this is a process of reducing code, making code writing more efficient, debugging code more efficient as well. So very simply, I'm going to try and illustrate what I mean by this, by code extraction and pattern recognition. So say now we have, oh, excuse me, my bad. So let's say we have this chunk of code over here. So in this chunk of code, we have a line here that does one thing, a line here that does another thing, and a line here that does something else. So in this chunk of code, we'll probably find this. You'll actually see quite often in programming. This piece of code here and this piece of code here do exactly the same thing. So let's say this piece of code returns the number 5 through a sum function where we say 2 plus 3. And this one just so happens to return the value 2, but it's 1 plus 1. So you can see immediately that they're both pretty much doing the same thing. Even though it's returning a different value, we can say in the programming world that these two lines of code are essentially doing the same thing. And this is the process of recognizing code repetition in our programs, and in doing this, we can actually go about improving our code. So what do I mean by this? Now that we identified that these two are doing the exact same thing, me as a coder can actually go about, instead of having to repeat the same chunk of code, I can have this code written once over here, and we have another random piece of code here, and instead of rewriting the same essential function, we can just tell our program to reference this one over here. So when the code executes, it runs, it evaluates it, it returns 5, and for whatever reason, let's say this one returns, any old value over here, and then this one will return 2 with a 1 plus 1. So instead of having to rewrite the code, we just tell the program to take these two values and push it through this and then return the value there. So that is the process of, identifying code repetition, and using that to our advantage. So the reason why we want to do that is because now you can immediately see that our code is a lot shorter. We didn't have to rewrite the same thing over and over again. And also, just as a coder, it's better to not have to rewrite the same thing over and over again, mainly because, or either because you're a bit lazy, or because it's just a tedious task, and the more and more we write the same line of code, or we just are a bit careless about trying to reduce code and become more efficient, you may find it's harder to read, it's harder to debug. A good example of debugging is we know for a fact, because we've written this code, we've tested it, that this piece of code here works incredibly well. But if for any reason we decided that we know this one works, but for some reason this one doesn't work, the program runs through and then it returns 8 instead of 1 plus 1. This isn't working very well, because now we have more lines of code to worry about in order to go through and see what's not working. But now that we just have this here, which has been improved, we know that this one works, and if for some reason this one also returns the wrong one of 8, this one returns the wrong number of 2, we know that if we just fix this chunk of code here, these two sets of what needs to be executed will always work correctly. So from the get-go, you can see that that is a very valuable practice in programming, where we use pattern recognition. So when I mean abstraction in programming, the skill of abstraction is knowing when you can reapply the same sequence of code in a recognized pattern. And that is what we did here, where instead of having the same thing repeat over and over again, we just reuse the piece of code that already exists in the place below here. Simple enough. So When we are programming, instead of having to write out chunks of code, there is a process of using flowcharts in order to first identify what our code needs to do and how we can use code abstraction to improve our code through identifying patterns in our code, and then from there we actually write out the code in an improved form. So when we use flowcharts for developing or designing our code, we use 4 symbols. So I'll just write out these symbols and then I'll give you an example of writing out a piece of code and improving our code through code extraction and pattern recognition before we actually go about typing it, which is quite a tedious thing to be doing, where we write, you want to go out, you write your program, and then you find that, it's clunky, it's inefficient, it's full of bugs. Whereas beforehand, if we actually went through the process of using flowcharts, it would actually make writing our program that much more easier and probably give us a lot better chance of success. So let's start with the 4 basic symbols of a flowchart. We have our arrow, which is our direction of logical flow. And we have our circle, and this is our start and stop command, or state. So we have start and end, and this is used to identify when our program starts or when our program stops. And then we have square, and in the square is represents our process, so what our program does. And then we have a very important one called, which is a diamond, which is called our decision. So if you get more into coding, you understand that this will be our if statements, while statements, loops, and such. So we have this here. Now that I've showed you these flowcharts, I'll give you a good idea of what code abstraction and pattern recognition would be like through pseudocode and flowcharts. So now we want to write a program that calculates the sum of 1 all the way through to 5. So using pseudocode, I'll give you a good example, and in this process I'll show you exactly what I mean by code abstraction and pattern recognition. So let's start very simply by starting our program. Start. So this is exactly how you would be creating flowcharts for code. In the real world, in actual development, this process is very, very much the standard practice in programming, using these 4 symbols. So we start our program, and immediately we need to instantiate our variable sum, because sum is what's going to carry out the total answer of what we want by adding the sum of 1 to 5. So from the start we instantiate the variable sum, and sum is going to be 0, because we want to start from 0 and slowly add all the numbers from 1 to 5. So now that we've instantiated our variable sum, we will now go about slowly adding all the way from 1 to 5. So the best way to do this in programming, I'll give you an example. We will go sum is equals to sum plus 1. Excuse me. So sum is equal to sum plus 1. So immediately we know that sum is equals to 1 as we go through the flow of our program. So sum started as 0, sum equals sum plus 1, and now it's now 1. So now you can imagine that the next process would be sum is equals to sum plus 1 again. Sum is equals to sum plus 1 again, and that would make sum become 2, because 1 plus 1 is 2. And you'd imagine that we'd be going down like this all the way through, and this will be essentially how we write our code. And right off the bat, you can imagine that this is very inefficient, this is tedious. So we're going to be using, we'll be using code extraction and pattern recognition. So we've already identified that there is a pattern here. Sum is equal to sum plus 1. We'll do it over and over again until sum is equals to 5. But that's inefficient, so we'll be using abstraction in order to improve our code and make it more efficient and easier to read. And we'll be using that with the other flow functions over here. So instead of going sum is equals to sum plus 1 over and over again until sum is equals to 5, which is very inefficient, we can go straight into our decision, and by drawing a diamond. like so. I'll just draw a big ugly one here. I'm sure you get the gist, excuse that. So we'll be using a condition here where we're going to say sum is equal to sum plus 1, and in here we're going to ask the question, is sum equals to 5? Because we want the sum of 1 all the way to 5. So is sum equals to 5? So now I had our program ask, is sum equals to 5? And we will have a yes and a no. Simple enough. So is sum equals to 5? Our no would imply that if sum is not equals to 5, we would re-execute this chunk of code up here. So instead of, like you saw before, going down and down, repeating sum equals sum plus 1, we're going to just have our program ask, is sum equals to 5? Nope. Or then redo it here. If sum is equals to 5, then simple enough, we just stop our program. Our program is done. It's done what it's needed to do. It's added sum from 1 all the way to 5. So you can imagine now, so just ignore this chunk here. So you can imagine now, when we start the program, sum is equals to 0, simple enough. Sum is equals to sum plus 1, sum becomes 1. And now we have the program asks, is sum equals to 5? No, sum isn't equals to 5, sum is 1. So what does it do? It re-executes the code, sum is equal to sum plus 1, that makes sum 2, simple enough. As you can imagine, sum plus 1 is 2. It will go down again and ask the same question. You can see how it's doing this loop. So through the process of recognizing our pattern, we've used abstraction, and we have now made our code more efficient because we know that this chunk of code works here. We know for a fact that this works. That makes our debugging easier. Instead of having to write this down again, we've actually made our code shorter and simpler to read. So we're going to go through this process over and over again. Plus 1 is equals to 3 until finally sum is equals to 5. And when sum is equals to 5, the program will stop. And then that's pretty much the program in a nutshell. We've written a program that we wanted the sum of 1 to 5, and I hope you understand that this is pretty much how it is done. And you can imagine now that I've written out this plan, when I go and actually write my initial chunk of code, like you see up here, we start our code program, and then we go sum is equals to sum plus 1, and then we have our conditional here, and then we end the program. Simple enough. Instead of having this sum is equal to sum plus 1 repeats itself again and again and again and again, which is going to become very big, to start with. And also, down the line, if for some reason one of these 5 chunks of code is wrong, our program will bring out the wrong answer, which is going to make debugging a bit of a nightmare, instead of where we just know for a fact that this piece has been tested, tried and true, and it works well. So that is pretty much code abstraction and pattern recognition in a nutshell for programming. I hope you understand. If you do not, please give me a comment below and I'll be happy to respond. It's very simple. And as I said before, this is actual real-world practices that you'll find developers use when designing programs and designing their code. I hope this made sense, and I hope this helped a lot. There'll be a lot more coming. Please rate and comment down below, and I will be seeing you next time.